So we're going to start a new unit today called Trigonometry. This will most likely be our last unit for remote learning, but if we have time, I do want to get through periodic functions as well. Okay, so today we're going to do a bit of a review. A lot of this you should have covered in grade 10, but it's good to just refresh our minds. So lesson 1 is called Introduction to Triangles. We're just going to talk about notation involved with triangles, special vocabulary, so on and so forth. So trigonometry is a branch of mathematics that studies the relationships between the sides as well as the angles in a triangle. So it's looking at if we know two sides of a triangle, can we find the third one? Can we find the angle between two sides of a triangle, so on and so forth. So before we can get to all of that mathematics, we need to review certain terminology that is associated with triangles. So there are two ways to classify triangles. We can classify them first using angles, or we can also classify them using sides. So when we classify triangles using angles, there are three options or three pieces of terminology that you should remember. The first is a right angle triangle, and it looks something like this. Okay, so with the right angle triangle, the triangle contains one right angle that has a 90 degrees. Now, I'm going to mention this once and actually multiple times throughout the course. Just because something looks like it could be 90 degrees, like here, don't assume it's 90 degrees. You have to always make sure that we have this little marking to indicate that that angle is in fact 90 degrees. So this notation right here is what tells us that this triangle has one 90-degree angle, so it's a right angle triangle. We also have acute triangles, and with acute triangles, essentially it's something that might look like this. With acute triangles, all three angles, so the triangle contains three angles that are all acute, and acute angles are just angles that are lower than 90 degrees. So this angle, and this angle are all less than 90 degrees. It doesn't matter if some of them are the same or if all three are the same. As long as they're all less than 90 degrees, we have an acute triangle. And lastly, the obtuse triangle. Essentially, it's something that would look like this. And here the triangle contains one obtuse angle, so an angle that's greater than 90 degrees. And we can see that angle right here. So the angle that's greater than 90 degrees. So again, using angles, we can classify them as right angle triangle has one 90-degree angle indicated with this marking, obtuse triangle where it has one angle greater than 90, and acute triangle where all the angles are less than 90. We can also classify triangles using their sides. The first one is the equilateral triangle. And the equilateral triangle looks something like this. Obviously, mine isn't perfectly equilateral, but what we're trying to get at is all three sides are equal. Okay, so with an equilateral triangle, all three sides are equal. That's where I got its name, equilateral. All three sides are equal. But consequently, all three angles of this triangle are equal as well. So the only way to form an equilateral triangle is if this angle equals this angle equals this angle. And you should remember from the past that all three angles in a triangle add up to give you 180 degrees. If we have three equal angles, we can divide 180 by 3, which gives us 60 degrees. So we know that all of these angles are 60 degrees. So with an equilateral triangle, all three angles would be equal, and they will always be 60 degrees. And all three sides are equal as well. The actual side lengths can vary. I can have a triangle that's 1 centimeter, 1 centimeter, 1 centimeter, or 7.5, 7.5, and 7.5 centimeters. Then we have an isosceles triangle. With an isosceles triangle, it's something that would look like this. Here, two of the sides will be equal, and the other side will be something different. That's why we use these dashed lines. So here I have one line. Here, this side also has one line, which means both of these sides are equal. This side has two dashed lines, which means this side length is different from these side lengths. Here, all three sides had one dashed line, which means all three sides are equal. But in addition to seeing two sides that are equal, two angles of the triangle will be equal as well. And so that would be this triangle, this angle here, as well as this angle here. Again, look at the angle symbols. There's only one curve here and one curve here, which suggests that both of these are equal. Same here. There was one curve, one curve, one curve, suggesting that all three were equal. With a scalene triangle, all the sides and angles of the triangle would be different. So I can add something like this maybe, where this side is different from this side, which is different from this side. Again, indicating that with dashed lines, I can say one dashed line here, two here, and three here. So that indicates that all three sides are different, but so are the angles. So I could put one angle notation here, two here, and three here. So you should become familiar with these symbols as well, what these dashed lines mean. What happens if I have two with a single dashed line and one with a double dashed line, and so on and so forth. So as a summary, we can classify triangles using their sides as well. Equilateral, all three sides are the same and so are the angles. Isosceles, two sides and two angles are the same. And scalene, all three sides and all three angles are different. You should have also learned in the past how to name triangles properly. There are certain rules that need to be upheld. So here it says, here's a triangle, label it ABC, label triangle ABC, okay? So the rules you need to remember are all vertices in a triangle are labeled with a capital letter. Okay, so a vertex is essentially a point where two lines meet. So this would be a vertex where this line and this line meets. This is the vertex where this line and this line meets. And this is the vertex where this line and this line meets. So whenever we're labeling vertices, they will have a capital letter. All sides in a triangle will be labeled with a lowercase letter. And a vertex and its opposite side will share the same letter. So what does that mean? Well, let's go back to the instructions. It says label triangle ABC. When you have this notation, essentially that's the name of the triangle, and the ABC, the capital letters, represent the name of each vertex. Now you have a choice here. I can call this A or this A or this A. It doesn't really matter as long as one of the vertices are A, one is B, and one is C. So I'm going to call this A, this B, and this C. If you chose to call another vertex A and another vertex B, again, that is totally fine. So I have my vertices and I've labeled them with a capital letter, so that's fine. I need to label the sides with the lowercase letter, but what I know is that the vertex and its opposite side will share the same letter. So let's start with A. Here is vertex A. The side that's opposite to it is here. So this vertex and this side will both be called A, but because this is a side length, it would be a lowercase a. Similarly, here's vertex B, and here's the side that's opposite of the vertex. They're both going to be called B, but because it's a side length, it would be lowercase b. And here we have capital C. Here's the opposite side. Again, it's a side length. It needs to have a lowercase letter. Now, to help you, sometimes what I suggest is if, for example, C and C, when you're writing really quickly, it's going to be hard to distinguish between capital and lowercase. You might want to put a line underneath the capital to tell you that you're dealing with a capital C at that point. Again, it's not necessary, but if it helps you, you can do that. Okay, so that's how you name triangles. Again, when it says triangle ABC, these are essentially the names of the vertices. You can put them anywhere. And then you just have to name the side lengths so that the opposite vertex and side length share the same letter, but the side length is a lowercase. So let's try that for these two triangles. It says label triangle JKL. So I'm going to randomly decide to call this J this time, and I'll call this K and this L. Again, capital letters for the vertices. Now I can label the side lengths. The opposite of this vertex is this side. I'm going to label it lowercase l. The opposite of this vertex is this side. I'm going to label it lowercase j. And the opposite of this k is this side. I'm going to label it lowercase k. Notice that I sometimes, for the L, do a little cursive L, because if I just wrote this, I'm going to get confused with any ones that I might have in my equations as well. Okay, so we've labeled this. Let's label this triangle. It's triangle MXY. So this will be M, this will be X, this will be Y. Again, you can randomly assign the vertex names. And then you do the side lengths. So the opposite of this is here. This is lowercase m. The opposite of this is here. This is lowercase y. And the opposite of this is here. This is lowercase x. I also try to do sometimes fancier or curved letters for my side lengths, just so I know what I'm labeling, because a lowercase and an x and an uppercase x and a lowercase y and an uppercase y can look very similar. Okay, the last thing I want to kind of show you, the last thing I want to kind of show you is how to label, how to name angles as well, because I think that's quite important here. So I'm going to go back to this example here. There's an angle here. There's an angle here. I'm going to put two dashed lines because it looks different from this angle, and we have this indication that this is a 90-degree angle. There are different ways I can call this particular angle. So this angle, I can simply call it angle A. Again, it's the angle at vertex capital A. That's fine. That's its one letter name. So angle A refers to this. So this would be called angle B, and this would be called angle C. I can also give angles a three-letter name. So I can call this angle BAC, or I can call it angle CAB. So what you'll notice is when I give a three-letter name to the angle that I'm indicating, so here angle A is always in the middle, and then I can choose to name the other vertex and vertices in any order. So if I do angle BAC, that means start at B, go to A, go to C, that's the angle that I'm looking at. Or if I name it angle CAB, start at C, go to A, then go to B, that's the angle that I'm looking at. Again, if you're choosing to name it with the three-letter angle name, whatever angle you're referring to, in this case angle A, would be in the middle. The other two vertices can be in any order. So let's try that here. So there are three names I can give to this particular angle. I can call it angle C. If I want to give it a three-letter name, again, I can call it ACB. So I'm looking at this angle right here. Noticing again, the C is in the middle because that's our angle of interest. Or I can call this angle BCA as well. So if I start at B, go to C, and go to A, again, I'm referring to this angle. And again, C, the angle of interest, is in the middle. So that's some notation that you should kind of remember. Another thing that you might see is how to label side lengths in a different way. So I know that this is side length. So let's go back to this example. We said that this was side length lowercase l, this was side length k, and this was side length j. Another way I can call this particular side length is I can call it jk. So this line above means look at the line segment that connects j and k. So the line segment that connects j and k is right here. I can also call this KJ. Find the line segment that connects K and J, or I could just simply call it L. So there are different ways to name these side lengths as well. So you just need to be familiar with all of these kind of notations. Okay, so just a quick recap. When you're naming triangles, the vertices are always capital letters, the side lengths are always lowercase, and you need to make sure that the same letter appears on opposite side lengths and vertices. And what we just kind of looked at is there's multiple ways of naming angles. We can name it with one letter where we indicate the vertex, the name of the vertex there, or we can name it with three letters where the angle of interest, the vertex of interest, where the angle is found, is always in the middle. We can name side lengths again with their one letter that's lowercase, or we can just look at the line segment that joins two vertices together. Give me 2 seconds as I switch to the next page. So now we're going to focus on right angle triangles. Remember, these are triangles that have at least one 90-degree angle. As it mentions here, so before we actually move on, the way this unit is separated is for the first 3 or 4 lessons, we're going to focus exclusively on right angle triangles. And then for the last 2 or 3 lessons, we'll focus on the acute as well as the obtuse triangles. So right angle triangles, we give the sides of the right angle triangles special names. So exercise, use the words opposite, adjacent, and hypotenuse to label the following triangles. Well, before we can do that, we need to know what each of these words mean. So the hypotenuse is always, the longest side of the triangle. Okay, so the hypotenuse is always the longest side of the triangle, and the easiest way to find it is that it's opposite to the 90-degree angle. So looking here, here is the 90-degree angle indicated by this box. The side length that's opposite to it is the hypotenuse. Similarly here, here we have our 90-degree angle. The side opposite to it is the hypotenuse. Then we have to look at an angle of interest. So the hypotenuse is always the hypotenuse. Its name never changes. It's always the longest side. It's always opposite to the 90-degree angle. However, the opposite and adjacent sides can vary based on our angle of interest. So let's focus on this first triangle. Here is our angle of interest, which is why I've indicated that angle with the angle notation. So the adjacent is always the side close to the angle of interest. So let's take a look at our diagram. Here's my angle of interest, and the side close to the angle of interest, or even the side that's required to form the angle of interest, is called the adjacent. And the opposite is the side away from, and really I want to use the word opposite, so the side opposite to the angle of interest, but we're going to say the side away from the angle of interest. So again, this was my angle of interest. One second, this was my angle of interest. This was the side close to the angle of interest, that's my adjacent, and the side away from my angle of interest is my opposite. Similarly here, here is my angle of interest this time. So the side close to the angle of interest will be my adjacent. So this will be my adjacent. And the side opposite of my, or away from my angle of interest is my opposite. Okay, so when you're trying to find these special names for the triangles, the right angle triangles, I should emphasize, this only works for right angle triangles, which is why it's under the heading right angle triangles, is you always want to find the hypotenuse first. It's always the side that's opposite to the 90-degree angle. Then you have to choose your angle of interest. Sometimes this will be given in a question, sometimes you get to choose it yourself. But define an angle of interest for you. The side close to that is your adjacent, the side away is your opposite. Here, we define this as our angle of interest, the side close to it was our adjacent, the side away was our opposite. Okay? So, the summary here is there's only one possibility for the hypotenuse of a triangle. The other sides of the triangle can either be called opposite or adjacent, depending on the angle of interest. So you can see here that both of these are pretty much the exact same triangle. They're pretty much the same side lengths, the same size, so on and so forth. Really, the only difference was because we defined our angles of interest as differently, the names of the opposite and adjacent swapped places. But the hypotenuse, again, always, there's only one side that can define the hypotenuse. So the homework for today, which is super easy, is you're going to take a look at this. You're going to take a look at this question where it says, state the length of the opposite side, adjacent side, and the hypotenuse in each of the following. So what you're going to do is you're going to take a look at this. The first thing I want you to notice again is that they're all right angle triangles. Okay, so this works because we're working with right angle triangles. And what the worksheet has done is this has indicated your angle of interest with this dot. So I'll do the first question with you. Okay, so when you're labeling triangles, again, you always want to label the hypotenuse first. Here's the 90-degree angle. Here's the side that's opposite of it. So I'm going to call it H for hypotenuse. They also show me my angle of interest here. So if this is my angle of interest, the side close to it will be my adjacent. So A is equal to, and the side opposite of my angle of interest is my opposite. So all you have to do is just label the side length. So the opposite here is 6 units, the adjacent is 4.5 units, and the hypotenuse is 7.5 units. Okay, that's essentially all you have to do for all of these questions. Okay, so I'll see you in the next video. So actually, before that, when you do this, send it to me through the Google Classroom. Thank you.